All right, next on tap is solving systems of equations. And, well, what is a system of equations? A system of equations is where you have multiple equations of the line. This first one is an equation on line. Actually, I label it. So we're going to call this equation 1 and equation 2. There may be just two, this is the simplest case, two equations of the line, or it might be three or even more than three. And what we do in solving an equation of a line is that, well, the easiest and yet less accurate technique for solving an equation of a line is to graph both of these lines, and we're interested in a particular geometric meaning. And what that is we're looking for the point where these two lines intersect, where they meet. That ordered pair will be the solution to our equation of a line. Now, I'm going to open up with not solving the equation online by graphing, but by using the substitution method. When is the substitution method appropriate? The substitution method works best if you have any one of the variables equaling a 1 or a negative 1. And a 1 is preferred to a negative 1, but either one of these two will work. So, looking at our system, when I say 1 or negative 1, again, I'm talking about the coefficient for the variable. So if you look at our first equation, on our x, it has a coefficient of 2. That doesn't really work. But the y, you don't see any coefficient. It's understood to have a coefficient of 1, and actually it's a positive 1. So equation 1 is good. Equation 2, the coefficient for the x here is 3, and the coefficient for the y is negative 1. So what's best is this equation 1 right here, because it has a coefficient of 1. So what I'm going to do, and I'm going to give this complete with instructions in a way. I want to solve equation 1 for, now this is where this comes in. Whatever coefficient had that whichever equation had the variable having a coefficient of 1 or negative 1, we want to solve for that variable. So here, equation 1 was best. We want to solve that for y. So here what I'm going to do is I'm going to bring equation 1 down over here, which is 2x plus y is equal to negative 6. Now I'm going to need to solve that for y. I'm going to subtract 2x from both sides. And I'm going to offset it a little bit because, well, this minus 2x and this minus 6, they are not like terms. What we'll get on the left hand side, y is equal to, on the right hand side, I'm going to lead with the x term. Negative 2x minus 6. That's an important result. So important, I'm going to call this result number 3. Okay? So remember what our goal is. Our goal is to get an ordered pair. This obviously is not an ordered pair, but it's an important result. And that what we're going to do is that since I solved equation 1 for y and got this, call it number 3, what I'm going to do now is I'm going to back substitute, they call it, or just substitute 3 into of the two original equations, the equation that I didn't use. So since I used 1, I'm going to have to substitute it into equation 2. So that's what that's going to look like. So substituting equation 3, this y is equal to negative 2x minus 6, into equation 2 right here. So what that'll look like, this will be 3x minus, now instead of y, I'm going to use this negative 2x minus 6. So I'm going to open up a parenthesis. It's important that I do that because we got all these negative signs floating around, and it's good practice to do it in general. So I substituted that in for y, and I have to continue on with the equation, which is equal to -4. And why was that such a breakthrough? That was such a great breakthrough because now we have this one equation and one unknown. We can solve for x. So what's going to happen is this will be 3x. I'm going to have to distribute this negative sign across the quantity, changing all these signs in here. So this will be, it was a minus 2x, this will be a plus 2x. This was a minus x. It will now become a plus 6. And finishing out, I still have that equal. I have to write that down. -4. I have to write that down as well. So now looking at this, we've got some like terms over here on the left-hand side of the equation. And what they are these x terms here. So 3x plus 2x is 5x plus 6 is equal to -4. That 6 and that 5 is giving me a problem. So first off, I'm going to handle that 6. Opposite of addition is subtraction. So I'm going to subtract off 6. That way I answer one of the things that are giving me a problem. So now I got 5x is equal to -10, dividing both sides by 5. I find that x is equal to -2. That's one part of the ordered pair. The second part of the ordered pair, and I'm running out of space. Let me do it like this. I'm going to have to substitute this into one of the two original equations. It doesn't matter which one of the original two equations I use. And what the original equations were. These are the two original equations, so I need to substitute it into one of these two. Doesn't matter. I'm going to use equation 1. So equation 1 was that 2x plus y is equal to -6. So what does that look like? I'm going to have, there's my hand, 2. Now in place of x, I'm going to use -2. So 2 times -2 plus y is equal to -6. So solving, we've got -4 plus y is equal to -6. Have to add 4 to both sides. And so what we'll get is y is equal to -2. We've got it. Our answer, remember we were searching for the ordered pair, so open up a parenthesis. The first number, -2, comma, the second number, -2. So that's solving a system of equations via the substitution method.